So this jumps to chapter 11, right? 11 is about probability and statistics kind of stuff. And we don't do near enough of this to really get good at it or, make much progress towards, like, you're going to do AP statistics in a year or two or something like that. I mean, this is just the minimum that's in the SOL, and we have to do it. I mean, it's kind of interesting stuff. And I think you'll find it, wow, this is different. I would rather have been doing that all year than what I've been doing all year. So, okay. So the first thing that we talk about here is called fundamental counting principle, which is something you probably already understand intuitively, right? If you have 3 pants and 2 shirts, how many different combinations of pants and shirts do you have? Right? For each pair of pants, you could have 2 different combinations, right? You could have the first shirt or you could have the second shirt. You have the first shirt, you could have the second shirt. How many different combinations is that? It's going to be 6, right? The fundamental counting principle says if you have this many choices times this many choices, then you got a total of that many choices. You go to a typical kind of question that they can ask is, you go to a restaurant, they have 3 salads, 5 entrees, and 4 drinks. How many different combinations of meals do you have? So you go 3 times 5 times 4. That's what this principle is right here. Not too hard, right? I mean, here, the example says, the photos show a Maryland license plate from 2004 on the left and 1912 on the right. How many more 2004 style license plates were possible than the 1912? Well, look at the one on this side here. There's 4 places for numbers. And how many different numbers might you have put into that first spot? 10, right? If you count the 0, it would go 0 to 9. There would be 10 choices, right? So you would have to say that there's 10 here, 10 here, 10 here, and 10 here. So how many total choices were there? 10,000. In 1912, when they first started making license plates, that was probably sufficient for all the cars that were there, but that's not sufficient now. So they still have 3 numbers here. Each one of those is going to have 10 choices for it, right? But then they start it with letters. And how many choices do you have for the letters? 26, right? So now that opens up a lot more possibilities. Now you've got 26 times 26 times 26. How much is that? Can you do it, Nathan? 1, 7, let me bring it up here. 17,576, which is 17,576,000. And so their question was, how many more plates did you have with this format than you had with that format? So just subtract. Minus 10,000. 17,566,000. Does anybody ever save videos on YouTube where you see how the naming of it? I mean, it's all some combination of capital letters and lowercase letters, and I don't think there's numbers. But, people just, I load things on there all the time. And, around the world, people are just, they load and they load and they load. And they just have this longer string and string and string. Every time they put one more digit on there, at the very least, it's going to be 26 different options. And if you count it as lowercase or uppercase, there you go. It could be 52 different options for just adding one more. So let's say they maxed out at 10 billion videos. Add a digit. Okay, now you've got, 52 billion videos, something like that, or 520 billion. Okay, so this is homework. Try to, and it's in the book, page 678, 9 to 11. If you don't have your book, or you just want to look up here, it's up here, right? The first one says you got 5 shirts and 4 pairs of pants. How many different outfits do you have? Right, so number 10, you're looking, it's like this. You're going to have 4 places. The first one's a letter. The next 3 are numbers. That's all they're saying. Did you get them? Man, I'm not going to leave this up forever. I mean, these 2 are like, what, 5 seconds? Don't even need a calculator for that. You probably need a calculator for that. Actually, you don't even need a calculator for that, do you? You could do that one in your head. How many choices are there for the first? 26. And for the second? 10 times 10 times 10 is 1,000. You added them, right? And 1,000 times 26? Done. We good? Okay. Okay. Now we move on to something a little bit different. How many different ways can you arrange 4 items? You know, if I have like 4 books on a shelf, how many different orders are there for me to put them in? So let's say I number them. I'm just going to call them each 1, 2, 3, 4. So here's the first way I could arrange them. 1, 2, 3, 4. Okay, now let's systematically go through and change what we can to see how many we've come up with. If I keep the 1 and the 2 in the same place, but I switch the 3 and the 4, that is another order, right? Now, I can't do anything else with the last 2. How about if I go 1 and I'll move the 3 into the second spot, and then I'll still have the 2 and the 4. Okay, and then what would the next line be? 1, 3, switch those 2, 4, 2. Okay, so we've exhausted all the possibilities for a 1 in the first spot and a 2 in the second, a 1 in the first spot and a 3 in the second. What comes next? A 1 in the first spot and a 4 in the second. Okay, and then what are the 2 possibilities? It could be 2, 3, or it could be 3, 2. Okay, are there any more possibilities with a 1 in the first spot? No, we did them all, right? We did every possibility of having 1 in the spot. So now we're going to jump to a column which is, okay, let's have 2 in the first spot and see how many we can come up with. Let's see, if I start with a 2, let me make the next one is a 1, and then it'd be 3, 4. And then if I go 2, 1, 4, 3, and then what would the next be? 2, 3, 1, 4, 2, 3, 4, 1, 2, 2, 4, right? We did the 1s and the 3s, so it's going to have to be 4s now. And that'll be 1, 3, 2, 4, 3, 1. Okay, so you can see the pattern here. Okay, I'll finish out the last 2 quickly. Now we could have 3 in the first spot. And we can have 1, 2, and 4. And if there's a 3 and a 1 there, then there's a 2 and a 4, and a 4 and a 2. And it's a 3 and a 2, so it's a 1 and a 4, and a 4 and a 1. 3 and a 4, so it's 1 and 2, and 2 and 1. And the last will be 4, 4, 4, 4, 4, 4. And 1, 1, 2, 2, 3, 3. Okay. 2, 3. 3, 2. 1, 2, 4, 2, 1, 3. 3, 1. 4, 3, 1, 2, and 2, 1. So we figured out how many total there'd be for 1 in the first position, 2 in the first position, 3 and 4. And that's everything. Okay. And the total is, there's 6 in every column, and there's how many columns? 24, right? So there's 4. 1, 2, 3, 4 columns. And there's 6 in every one. And in fact, the 6 are organized into 3 groups of 2, right? There's 1, 2, 3, and every one of them, right? There's 1, 2, and 3. So it's actually 4 times 3 times 2, which is 24. 4 times 3 times 2. So you want to figure out how many ways you can arrange 4 distinct items. It's actually 4 times 3 times 2, 24. So how many ways can you arrange 10 distinct items? Okay, we could go through that whole big thing. It would be a massive spreadsheet there, but in the end, it'll be 10 times 9 times 8 times 7 times 6 times 5 times 4, all the way down to, I mean, usually we say 1, but what's the effect of multiplying by a 1? It doesn't matter, right? So you don't really need to show a 1 at the end there. Now, when you do that kind of operation, multiplying, by a number, and then every number less than it until you get to 1, that is called factorial. And it's represented with a 10 and an exclamation point. 10 factorial. Right? That's the word right there. And the definition is n factorial is n times n minus 1 times n minus 2 times n minus 3. That was supposed to be a minus, all the way down to 1. Now, if the numbers are small, you could do that fairly easily, either in your head or, with a little bit of calculator operation. The truth is your calculator does this for you. Right? If you go in the calculator to the math menu, watch this, go math, and then all the way on the right, PRB for probability. And you can see the number 4 option right there. There's your exclamation point for factorial. So if you have to do factorials, by all means, use the calculator to do it. I mean, we just did 4 factorial, and we got 24. Let's just do it to verify that it works like that. Right? So we go 4, and then we go math, PRB, 4. There's 4 exclamation point. When I hit enter, 24, which is what we got by hand. Right? What if we want to do the 10 factorial? 10, math, PRB, 4. 10 exclamation point. 3,628,800. Okay. Now, we keep in mind, the reason we're doing this is because it's telling us how we can organize a certain number of things. right? If I want to know how many different ways can I put 20 students into seats, it would be 20 factorial. 20 students into 20 seats, 20 factorial. Calculate it. Okay. Now, when you count the number of different orders you can put something, that's what's called permutation, right? Permutation is the number of different orders you can put some things into. So if you look at their example here, it says, how many ways can you file 12 folders, one after another in a drawer? Okay. So, I mean, you could say, in a way, you could say, well, the first position, I've got 12 choices. The next one, since I've already filled the first position, I've only got 11 choices. The next position, I have 10, and so on, all the way down to 1. In the end, 12 factorial. So you do the 12 factorial, and you get your, this is how many different ways you could have done this. Now, keep in mind the context of us doing these fundamental counting principle or factorials. This is in a chapter of probabilities. So if, for example, you wanted to know, well, what is the probability that they would have been in any particular order, then it would be 1 over that, right? There's that many different possibilities, and you want to know what's the possibility that's in exactly that order, 1 divided by that. It's really, this is in the first section of the probability chapter for that reason. We don't really do most of the rest of the probability stuff anyways, but so 12 factorial and you get that. How would we solve this one? In how many ways can you arrange 8 shirts? What would be the math? What is it? How many different ways can you arrange 8 shirts? 8 factorial. 40,320. This seems like a lot. Go try it at home. Put 8 shirts in there and start done. Tell me when you're done. 40,320. Okay. So try to do these are the next set of homework problems. 12 through 14 are these right here. They're just calculating factorials. And then these are, this is a word problem. It's got 2 different ones. In how many ways can 4 tires be arranged? And then if you include a spare tire, how many tires is that going to be? Get them? And this is 24, 20, just right. So I mean, it's all just number crunching. You all right with that? Okay. How many different ways can you arrange things? Permutation, and you're just using factorial. Okay. Now, in a more general sense, you're not arranging into the same number of positions that you're drawing from. And so then we need a formula for permutations. And that is the formula which is on the formula sheet. If you look in the middle on the right, where it has that, that's the permutation formula. I mean, the reality is you're probably never going to use the permutation formula because it's also in the calculator, and you would just plug into the calculator. But there is a formula for it. Right here, it says there's 10 students in a race. First, second, and third places will win medals. In how many different ways can 10 runners finish first, second, or third? Well, let's see. In first place, you could have 10 different people, right? Now, if one person takes that position, then how many different people could take the second position? Only 9, right? Because you've already filled the first with one person, and then now you fill the second position. How many different people then are competing for the third position? 8. So it's 10 times 9 times 8, which is 720. Right? That's how many different ways 10 runners can finish first, second, and third. Right? It matters who's in first, who's in second, who's in third. Now the formula for this looks like this. And whether or not you use the formula, you need to know what it is. I mean, you shouldn't be surprised by it. And that you could be asked a question which uses that, which we will in the homework anyway, so you'll see that. But when you use this formula for permutation, N, P, and R, okay, the P stands for permutation. The N stands for how many people are you choosing from, right? So how many people you're choosing from, and this one is 10. Right, so this is going to be the 10. The R is how many positions are they going into? In this case, how many was it? 3. Right, so you're going to go 3. So really, this is what it should be: 10, P, and 3. Right, if I plug into the formula, that would look like this. It would look like 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7 factorial. Which you could do that in the calculator. Now that you know where the factorial is, math PRB 4, you could do that. But go back to that same menu, math PRB, and notice the number 2 option. There's the permutation directly. You don't need to be doing any math with factorials. You're just going to go right for the NPR, right? And there is a particular way you got to enter this in. Right? If you go like this, go back to the main screen, and first put the 10, right? Whatever the N is, put that in the calculator first. Then go math PRB, this time 2 for permutation. And then put the 3 in. Right? On the screen, it has to look like that. It's got to be the 10, then the NPR, and then the 3. So the calculator understands N is 10, R is 3. And you hit enter. 720. So permutations. Okay, and how many different ways can 15 runners finish first, second, and third? Right, as a permutation, 10 P R. What is the N going to be? 15. You're drawing from 15, right? 15 P, and then how many positions are they filling? 3. So that's the math you have to do. And that's what you're going to put into the calculator. 15 math PRB 2. Now I put in the 3. 2,730. Now I don't remember if I have that on there. Okay, I'll get to that in a second. So the homework problems to do right now are do these 3 permutations, right? And then answer a word kind of question, word problem kind of question. 15 students trying to get in line into 10 slots to be seen. Great. If you have any issues with the calculator, raise your hand, holler, send a smoke signal. Would it ever be possible for the number on the right to be bigger than the number on the left? No. It's always going to be the case that the number on the right is either bigger or equal to the number on the left, because that's the bigger group of number you're choosing from is on the left, and you're putting them into equal or less positions. You finished, Nathan? Easy stuff? Would you rather be doing this or rational functions? This? I think so. You good? Everybody? Okay, note that what we did at the first with the factorial is also a permutation. If I put 7, if I say how many different ways can I arrange 7 books on a shelf, that's saying I'm drawing from 7 and I'm putting them into 7 positions. So that is like this, 7p7. Now, before when we did that, we did this, 7 factorial. See what you get if you do them both. Right? If I go 7 factorial, 7 math PRB 2. Clear. I did 2 and I meant to do clear. 7 math PRB 4. 5040. Okay, now I'm going to do the permutation. 7 math PRB 2. And we're going into 7 positions. Enter. 5040. Right? So they're all permutations. Okay, they're all permutations. And the one thing that you have to keep in mind, the most important thing about this is, in permutations, order is important. It's the whole thing you're dealing with here, is how many different orders can you put something in. Now, if order is not important, then we got another way that we calculate it. In one of these scenarios here, order is important, and in the other one, order is not important. Right? The first one says, a chemistry teacher divides his class into 8 groups. Each group submits 1 drawing of the molecular structure of water. He will select 4 of the drawings to display. How many different ways can he select the drawings? Okay. The next one, you will draw winners from a total of 25 tickets in a raffle. The first ticket wins 100, the second wins 50, the third wins 10. How many different ways can you draw? Which one of those is order going to be important? In this one, if you get the first, you're getting more money, right? So it matters which the order is. This would definitely be a permutation, right? This would be the permutation 25p3 for 3 positions. But here, it doesn't matter the order that he picks them. It only matters like which 4 got picked. That's called a combination. Okay? When order does not matter, that's a combination. Right? When ordered is not important, the number of distinct groups that can be formed is called combination. Right? There's always going to be more permutations and combinations, right? Because if I say, for example, how many different ways could I arrange 5 people? I mean, that's going to be 5 factorial. But that same 5 people, no matter what order they're in, it's still the same 5 people. So you would always have less groups than you would have orders of the things within the group. And that is actually apparent if you look at the 2 formulas, right? The formula for permutation, which you have this on your thing. Here's NPR is n factorial, n minus r factorial. And here's combination, NCR, n factorial divided by n minus r factorial times r factorial. So we have an extra thing in the formula, and it's in the denominator, right? So this part of it here is permutation, and then you divide it by something, so it's going to be smaller, right? That is always going to be less than that. So a lot of the challenge in these problems is trying to figure out, is order important? Because if you figure that part out, then the rest of it is easy. Then you just do whatever it is you do for that one, and you probably do it in the calculator anyways. Okay. So in that problem that we did before, since we're going to assume that it didn't matter the order, it only mattered which 4 got selected for display, then he was picking from a larger group of 8. It was a combination because order wasn't important, and he was going to select a total of 4. Okay, so go back to the same menu, Math, PRB, and it's number 3. NCR for combination is number 3. But again, like permutation, first you need to enter the n, the bigger number, before you go to the menu. Clear. So 8, Math, PRB, 3. And we're going into 4 positions, so that is enter 70. 70 different groups. It's good, Alicia? Okay. So do those, right? There's 3 combinations to do. And then there's a word problem kind of thing. Good? Denise? Jalen? Everybody? Okay. So that's the lesson. The homework, you've done all this except for this, right? And in those last 3, you need to go do those that you have to choose. Is a combination or permutation, and then do it. Okay? And then you're done. And that is the homework. And then we take a quiz next time over the combination or sequencing series.